Hello, everybody. This is Miss Pollard, and I'm going to read to you the next two sections of our book. There's going to be a couple questions in here, and I will. How am I going to do this? I'll pause. I'll do like a page break kind of thing, and let you guys answer your questions, and then move on. So our first section that we're going to be looking at is section 2, and this is the composition and structure of molecules. So I'm going to start reading right here. And it says, suppose you collect rocks. How could you describe them? You could describe them by what the rocks are made out of, as well as the sizes and shapes of rocks. How is describing molecules similar? We'll move that up a little bit and start right here. Just like rocks, molecules come in all sorts of shapes and sizes. Some molecules are small. For example, a molecule of ammonia, which is found in cleaning supplies, contains 4 atoms. Similarly, methanol, used in fuels for race cars, contains 6 atoms. Other molecules are much bigger and more complicated. Caffeine, found in some sodas and teas, is made up of 24 atoms bonded into 2 ring shapes. On the other hand, some molecules have thousands of atoms. All of these molecules are different, so how can scientists tell them apart? A unique molecule always has a unique composition and structure. So we're going to look first at composition right here. The atomic composition of a substance includes both the types of elements that make it up, as well as the specific number or ratio of atoms of each kind of element that make it up. Both aspects of composition affect its characteristics and what it looks like. Look at figure 2a. A molecule of water has 2 atoms of hydrogen and 1 atom of oxygen. It is often written as H2O to represent that there are 2 hydrogen atoms and 1 oxygen atom in a water molecule, in one molecule of water. A molecule of hydrogen peroxide, on the other hand, has 2 atoms of hydrogen and 2 atoms of oxygen. It is often written as H2O2. So scroll down, and here's our figure 2a they were talking about. This is water, and we have our hydrogen peroxide, and it's foaming because somebody put it onto a cut on their finger, it looks like. And below it, it says molecules can differ in the elements that compose them and the ratio of those elements. Both water and hydrogen peroxide are made up of only the elements hydrogen and oxygen. The 2 compounds have different characteristics because they have different numbers of these 2 elements. I'm starting right here. Though these 2 molecules differ in only 1 atom, they form molecules that have very different characteristics. If you drink and bathe in water, but you would not drink or bathe in hydrogen peroxide. Instead, you use hydrogen peroxide on cuts as a disinfectant. Right here, structure. Models of different molecules vary in their composition, but another factor that affects the characteristics of a substance and can even determine its identity is the chemical structure of its molecules. Let's look at chemical structure right here. Chemical structure is the specific way in which the bonds and atoms are arranged within the molecules of a substance. Remember, we talked about bonds with the ball and stick atom models, where they had the 2 or more atoms joined together with the gray lines between them. Those were the bonds. So we're going to start right there. Butane and isobutane are 2 molecules that have the same composition but different structures. Observe the models of the 2 molecules in figure 2b. Butane and isobutane both have 4 carbon atoms and 10 hydrogen atoms. However, butane has 4 carbons arranged in a chain-like structure, and isobutane has the carbons arranged in a triangle-like shape. Because of their different structure, their characteristics are also different. Butane is often used as a fuel in camping stoves, and very pure isobutane is used as a refrigerant in refrigerators. However, sometimes isobutane is mixed with other gases and used in camping stoves. I'm going to scroll down here. So we're going to look at this right here. So molecules with the same composition but different structures. And again, this is our butane on the left side. It says chain-like structure, and we're following that chain of carbons. So see, it says C right here. Doot, doot, doot. That's a chain. And that chain-like structure makes up butane, and butane is used in stoves. This is a butane canister here. And then on this side, we have isobutane, and that one, look at the chain here. It only goes 3 carbons in a row, and then it has a branch going off of it. So it roughly makes a triangle-shaped structure. And that is used for refrigerant. So I'm going to skip down to here. Sucrose and maltose are another example of 2 molecules that have the same composition but different structure. Sucrose is the ordinary sugar that people typically use to bake with or to sweeten their cereal. Maltose is the kind of sugar that gives malted milk drinks their particular flavor. Both molecules have the same exact number of carbon atoms, which is 12, and hydrogen atoms, which is 22, and oxygen atoms, which is 11. However, their structure is different, so their molecules have different shapes. The different shape results in the different taste. So scroll down here. And this is your first question. So you're supposed to look closely at this molecule to answer the following question. Your question is, identify the atomic composition of the molecule, then describe its chemical structure. So we look at this molecule and we see some different atoms. White is usually hydrogen, black is usually carbon, red is usually oxygen, and this is our mystery structure. So you could say, just call it blue if you want to, because it's not been identified here. So here is where you will answer this particular set of questions. So I'm going to pause here, and at this point, the rest of this reading from here down where it says crystals and polymers, at this point, this is going to be an extend section. So if you are super interested in atoms and how they work, this is where it would be great for you to go ahead and read on and answer the questions if you are interested. You do not have to go further than section 2 above. I hope this is helpful, and if you have any questions, please write them down in your science journal and bring them to class on Friday, and I will do my best to answer them. Have a great day, and thank you for watching. Bye-bye.